A nuclear explosion is the instantaneous release of a tremendous amount of nuclear energy. A nuclear weapon is the instrument which brings about the release of this energy. Nuclear energy comes from two processes that alter the nuclei of atoms. One is fission, and the other is fusion. First, let us consider the principles of nuclear fission. When the nucleus of an atom of a fissionable element, such as uranium-235 or plutonium-239, is struck by a neutron, the atom splits, or fissions, into two or more parts. The combined weight, or more correctly, the mass of these fission fragments, is less than that of the original atom. The lost mass has been converted into and released as energy. During and as a part of the fission process, another reaction has also occurred. 2 or 3 neutrons have been released and may strike the nuclei of other fissionable atoms, and thus continue the fissioning process. Essentially, it is a continuation of this action that makes a fission reaction possible. Because stray neutrons are always present, there are limits to the amount of fissionable material that can be assembled without producing a premature reaction. If the amount or shape of the active material is such as to permit the neutrons given off by spontaneous fission to escape after only a few fissions, the nuclear reaction is not self-sustaining, and the condition of the mass is said to be subcritical. If the configuration and amount of active material is such that one neutron from each fission does not escape and goes on to fission a new atom, a continuous self-sustaining reaction known as a chain reaction is created, and the mass is said to be critical. The sun is constantly creating and releasing energy created through a fusion process. Fusion is the second process through which energy is liberated from the nuclei of atoms. The process of fusion is the reverse of fission. In fission, a nucleus of an atom of high atomic weight is broken up to form other elements. But in fusion, the nuclei of 2 lighter elements are combined to make a heavier element and to release a great amount of energy. Fusion in nuclear weapons utilizes 2 of the isotopes of hydrogen to release energy. They are deuterium and tritium. Fusion will occur when the nuclei of the 2 atoms are given enough energy so that they can penetrate the repulsive force surrounding the nuclei. When the nuclei of deuterium and tritium undergo fusion, a helium particle will be created and a high-energy neutron emitted. A total energy of 17 million electron volts is liberated in the process. In order to produce a fusion reaction, the conditions of high temperature and high pressures found in the interior of the sun must be duplicated.